Okay, so this is going to be the Fusion 360 tutorial for how to make an enclosure for the MIDI mixer. To get started, what we're going to do is we're going to navigate over to Easy EDA, and in here you can see that I have the PCB view pulled up for the PCB that we designed for the MIDI mixer, and we're going to use this as kind of a reference point for being able to design an enclosure that is going to allow all of the components, the potentiometers, the sliders, and the push buttons to poke through the faceplate of the enclosure. So to get started, what we're going to do is we're going to actually go through and export this as an SVG. And we want to make sure that it's exporting as SVG. And this size 1x is really important. We want it to be actual size. And your settings should look somewhat like this. Make sure you're doing black on white for this printout. And we're going to click Export. And once that is done, we can open that up. And here you can see kind of just this kind of simplified version in view. And we're going to print that. One of the important things when you're printing is make sure that it's not shrinking the image down at all. Again, we want this to be life size. We're going to be using this as a actual measuring device to make sure that we're designing this correctly. And so make sure you check your settings. If it's scaling it or anything like that, change the scaling to 100% and print it out. Once you have that printed out, then go ahead and get a ruler or calipers, and you actually want to start kind of measuring where things are on your PCB. You can also verify this with your soldered real-life PCB as well. But what you ultimately want to come down to is something that looks like this, where you have gone through and kind of measured kind of significant distances in our design here. So one of those very first things is to make a kind of measuring of the overall length of the board. In this case, you can see that I've marked that at 178 millimeters for mine and 70 millimeters tall. And the main components that we want to focus on are our sliders here. So you can see that I've got 2 in my design. And what I'm looking for in this case is I was kind of looking for the center point here. And so I can see that I'm kind of 10 millimeters away from the edge, 5 millimeters from the bottom of the edge, and that the overall length of this is 55 millimeters. And I'm going to be making some adjustments there to kind of, again, we don't have to make it big enough for the entire slider to poke through, just that little arm that's going to push up through. Over here, you can see, again, some measurements made for each of the potentiometers that I put in my design. Again, looking at kind of the distance from one of the edges, both kind of vertically and the horizontal distance. So here you can see mine's 24 millimeters from here and 50 millimeters from here, as well as kind of how big I'm going to want that opening to be. One of the most important things that you're going to be making as a design consideration is tolerances. And so, for example, if the knob for your rotary potentiometer is 7 millimeters, then you might make that opening 8 millimeters to, again, just give it a little bit of width on each of the edges, so it's not, you're not trying to make it exactly the same distance. Otherwise, it would create too much friction to be able to turn the knob. Over here, so this looks like one of the most complicated, but actually shouldn't be too bad features to make, and that's these soft push buttons that are going to be poking through. What's nice about them is if you've used good design rules, these should be 15 millimeters apart, center to center, in a grid pattern. And so what you really just need to sort of figure out is kind of where the first one is in reference to the edge. And so here you can see that this one is about 13 millimeters from the right edge and about 12 millimeters from the bottom edge, and that's the center. With this, what we're going to be doing is, since the push buttons are actually square, and the push buttons themselves are 10 millimeters by 10 millimeters, I'm going to be making 11 millimeter openings. Again, just a little bit of tolerance on each side to let that button push through and move easily. And then what I can do is I can just then pattern that 15 millimeters apart. So at the end, you can see I've got a little extra here. It says a ½ inch extra. We are going to be making an enclosure that's going to be slightly bigger than the PCB itself. If we made it the exact same size, the PCB wouldn't actually fit in. And so this is just a note to myself saying that I'm going to add about a ½ inch extra on each side, just to make sure that our board's going to fit in. Okay, so that's going to be kind of my reference document. To get started, we're going to jump into Fusion 360 here. And you will want to take note of kind of the the system of units that you're working in. Mine's set up for inches. You can do this in millimeters. I'm going to be doing a lot of conversions, and Fusion 360 is pretty good about letting you work within that. So to get started, I'm going to start off by working with a 2-point rectangle, and I'm going to have it just kind of facing down here. Okay, and I know from my previous measurements that I'm at 70 millimeters tall, and so I can do 70, and if I type mm here, even though I'm working in inches, it'll actually still let me put in metric units. And so that's 70 millimeters by 178 millimeters, and I'm going to hit enter. Okay, and so right now this is the true-to-life measurement of the outside of my PCB. Now I did mention I'm going to add some extra later on, and we'll get to that. Now, one of the things that we're going to be doing a lot is working in not actual lines that are going to turn into real geometry, but construction lines. And so I'm going to actually make that a construction line. And what this is going to serve as is just a reference point. You know, when we make real lines, those are going to be things that are going to be actually cut on the laser cutter. And so we'll just need to make sure that we're careful to distinguish between lines that we're going to want to use at the end of this exercise, whereas lines that are just going to be useful for kind of the references versus construction. So one of the things that I'm going to do is I'm going to sketch just a regular line, and I want to find the center point here. Again, I'm going to make this a construction line because it's just going to be a reference point. And so I'm just going to go corner to corner to kind of find the center. And the next thing I'm going to do is I'm going to create a rectangle, and this time I'm going to do a center point rectangle. Okay. And this one is going to be not a construction line, because this is actually going to be defining the real overall profile of the cut that I'm going to make. And so I'm going to kind of go to the center point here, and you can see it snaps there. And I'm going to drag this out, okay? And it looks like I'm going to make this about 4 inches by, we'll say, you know, maybe 8.5 inches, like that, okay? Okay. And so with that, what we can see now is this outer rectangle. That is something that is going to be actually cut out. Okay. So what I can do is I can go ahead and just kind of remove some of these reference lines. I don't need these so much anymore. Now, as I continue to add features, I'm always going to be kind of using these points on the actual PCB as a reference because, you know, again, if we visit back here, all of these measurements were made from the edge of the PCB. And so we'll keep that in mind as we design out our next few features. Okay. So what we're going to do is we're going to start with our linear potentiometers. And so with these, again, I'm going to kind of look here, and I'm going to say, okay, it looks like I come in 10 millimeters to center, and then it's kind of 6 millimeters up. So I'm going to kind of just make a box here that's going to be kind of 5 by 10, and that's going to show me kind of where I need to start. And so I'm going to bring in a 2-point rectangle. Again, this is just going to be a reference line. And so I'm going to come to this edge, and I said, okay, I need to be 5 millimeters that way and 10 millimeters that way, and I can hit enter. And that tells me kind of where the start of the center of my box should be. So I'm going to make a line now, and I say, okay, well that is going to be, I believe we said 50 millimeters tall. Okay, and if I hit enter, I now have to ask myself, does that seem right? That looks a little bit odd. So let me kind of double check here. Okay. Yeah. It looks like it's not quite going up as far as it should, so I'm going to double check my measurements here. Okay. So that's 70. Okay. So I did make a small mistake. That should be 60 millimeters instead. So again, kind of looking at that, it looked like it wasn't quite right. It looked like it wasn't going up far enough. So again, I'm going to do 60 millimeters. Okay, and that looks a lot better. Okay, so at this point I know that kind of the opening for my linear potentiometer, again, that little arm that's going to poke through, should be kind of following along this line. Again, I'm going to come over to my rectangle and do a center rectangle. I'm going to come to the center, and the overall height we know is going to be 60 millimeters because we fixed that. And then for the opening here, I'm going to have it kind of be an opening of 2 millimeters. Now when I make this line, I do want this to be a real line because this is going to get cut out to allow us to have that poke through. So as I come through, again, 60 millimeters by 2 millimeters. And if I hit enter, again, now I can see that there is in fact a little space there that is going to let our linear potentiometer go through. Okay, now what we're going to do is we're going to perform that same exercise over again, and this time we're going to make it for the one that is right next to it. And it turns out that that one is 24 millimeters away from the edge. So again, I'm going to come back to my rectangle here. I do want this to be a construction line, and I'm going to say that we need to be 5 millimeters from the top and 24 millimeters from the edge. Okay, I'm going to do a line again. Again, this is going to be a construction line, and 60 millimeters up. Okay, and now I'm ready to do my center rectangle. Okay, and I want this to be a real one. And I'll come here and again make the same kind of thing. So it's going to be 2 millimeters by 60 millimeters. Okay, and now, again, you can kind of see through the bold lines through all these little guidelines, you can see I've got these two, nicely placed openings for my linear potentiometers. Okay, so that should take care of these two areas. Let's start talking about these rotary potentiometers, these knobs that are going to push through. Now I'm looking, and it looks like the first one is kind of 50 millimeters from the edge and 24 millimeters from the bottom. So again, we'll come over here, we'll do our 2-point rectangle as a construction line, and again we said that was 24 millimeters up and 50 millimeters over. Okay, and that's to the center. Okay, now at this point I need to again make a thoughtful decision about, okay, well I need to make an opening. What shape is it going to be? In the case of our rotary potentiometers, it's going to be a round shape. The diameter on my potentiometers is about 7 millimeters, and so I'm going to open it up just a little bit more and make an 8 millimeter opening. Again, I don't want that to be a construction line. This is going to be a real line that's going to cut through it. And so I'll say 8 millimeters there, hit enter. Okay, and there again, you can see that that's going to create a real line that we can cut through. Okay, our next knob, according to my little diagram here, is again 50 millimeters across, but 26 millimeters from the top. So you can see when I designed this, it wasn't kind of perfectly spaced or centered, but that's okay. We want it to be accurate now that it's all kind of soldered up. And so I'm going to come over, and again, I'm going to choose my 2-point rectangle with the construction line. And this time I'm going to come over from the top edge, and I'm going to come down 26 millimeters and come across 50 millimeters and hit enter. And I'm going to make a circle. I want that to be a real one. And again, same size. We want 8 millimeters and hit enter. Okay, and so now I've got those two. Now for the ones that are right across from this, again, let's use our reference. So on mine, it looks like I'm 31 millimeters kind of from the center of these. And so for that, I can use a line. That's a construction. I can come to the center here, and I can just measure 31 millimeters out to the edge. Okay, I'm going to do that again over here. 31 millimeters from the edge. Okay, and so now I know that I should put, again, similarly shaped circles here. Okay, these are going to be real ones. So we do 8 millimeters here and 8 millimeters here. Okay, so now I've got the 4 openings for my rotary potentiometers. Okay, so that leaves us with our push buttons. So again, let's look at our reference document. And it looks like this first push button that I've identified that it's 13 kind of from this edge and 12 from the bottom. Okay, so we'll go to here. We're going to make a construction line. Okay, and so here we said that we're 13 millimeters from the edge, 12 millimeters from the bottom. We hit that. Okay, and that's going to be to the center. Okay, and so we know that the square that is going to kind of push through. Again, the push button itself is 10 millimeters by 10 millimeters. In this case, I'm going to make mine 11 by 11, just to again open it up a little bit. And so for that, again, we're going to do a center rectangle. We want this to be a real one. And I'm going to go 11 millimeters. Oh, that's 1 millimeter. That's 11 millimeters by 11 millimeters. Okay, hit hit enter, and there's the opening for my first push button. Okay, now we need to kind of like repeat these over and over again. To do that, I'm just going to kind of make some lines. So again, I can just go into line mode, and I'm going to make some construction lines. And so I'm going to come across 11 millimeter. Oh, nope, not 11. We know that these are 15 millimeters apart. So I'm going to go 15 millimeters in that direction, and 15 millimeters in that direction. And again, now I can do a center rectangle, a real one. And again, just going to make another. I keep typing. Okay, so there's another button there. Okay, and I can keep making these center rectangles, 11 millimeters, 11 millimeters. Okay, so now I can see I've got 3 of these, and I'm just going to keep repeating that until I get all of my buttons laid in. So again, 15 millimeters that way. Okay, and 15 millimeters that way. And one thing you can see that I'm doing is I'm using the right click to do the repeat construction. And this just saves me a little bit of time to not have to kind of go back into here each time. And so that's a little trick that you can use to save yourself a few mouse clicks. Okay, almost done on my last row here. Okay, now I know that looks a little bit messy, but you can see kind of through here that we've got that kind of 4x4 arrangement of these buttons. Again, yours will be a little bit different, but this should be in about the right shape. Now, one of the last considerations we're going to need to make is we're actually going to end up splitting this faceplate into two surfaces, and that's because the height of these buttons is actually going to be a little bit lower than these potentiometers. And so what I'm going to need to do is to kind of come in here and find a place where I'm going to kind of divide this out. And the way that I'm going to do that is with a 2-point rectangle. And I'm going to come in here, and the height of this is going to be kind of relatively set. And so if that says 3.378, sure, that sounds fine. The width of this is going to be 5 millimeters, and that's going to be the thickness of our material. And as we kind of build out the geometry of this, it'll become a little bit more obvious as to why we've chosen that particular amount. And so at the moment, we should see that we've got kind of this overall kind of faceplate view of what we're working on. Oh, you know what? I messed up, so we're going to come back to this top view, rotate it down this way. And when I made that, I wasn't at the right. I need to make sure I'm all the way up here. Okay, when I make that little division here. So I'm going to come over here, and we're going to go right there. Yeah, so 4 inches sounds better. I thought that looked odd. Okay, again, 5 millimeters wide, and that will be our division point. Okay. All right, so now let's talk about how to actually turn this into a real faceplate. So we're going to do an extrusion. Okay, so we're going to come up to Create and click Extrude. You could also just click E for one of the quick keys. Okay, and we're going to extrude both of these surfaces up, and we want to do that 5 millimeters. Okay, and so when we do that, okay, we're going to get this piece, and that's going to be kind of the one part of our faceplate. One of the other things that we're going to do is we're going to come back in here to Sketches. Okay, we're going to kind of turn off these bodies for a second. Bodies are kind of solid objects, and sketches are kind of just these little guidelines that we've done. Okay, and we're going to extrude again, and this time we're going to select both of these, and we're going to extrude that up again 5 millimeters. Okay. It'll give you this warning that it's like, hey, this is invisible. That's okay. So we want to make sure that it's a new body. Okay, and so if we turn off our sketches and on our bodies, we should see that we've got these two different plates, and we need to move them apart because again, we're going to stack these because the heights of the inputs are going to be different. And so to do that, you've got a couple of options. So I'm going to say move, and I'm going to select this body. And what we want to do is we actually want to move it down a little bit, and the amount that we want to move it down is negative 10 millimeters. Okay. And so when we look at it, there's going to be a little gap there, and that's actually pretty much the gap between the two interfaces, where the buttons are going to push up through here, and the potentiometers and everything are going to push up through here. Now we need to fill this gap with material, and so what we can do for that is, again, we can turn off the bodies, we can turn on our sketches, and we're going to extrude one more time. So again, extrude, and we're going to extrude this little piece, and we're going to extrude it down negative 5 millimeters. Okay, we're going to click OK, and again, we can turn on that body and turn off the sketches, and you can see here that it's created a little step plate for us. So that's good. So now at this point, we have a faceplate that would match the hopefully the surface of the PCB board, rather the PCB that we created. Okay, but this isn't a completed box. We need to kind of add a little bit more geometry to this. And so what we're going to do is we're going to kind of sketch on the surface of this a little bit more of what we want to accomplish. And so to do that, we need to kind of make a front, a back, a left, a right, and then a base plate for this as well. So what we'll do is we'll start kind of making the faceplate for this. Now we're going to try to do this as a solid piece, and we can see that it's going to kind of have this little step in it, and that's okay. So what we will do is we're going to sketch, and I'm going to sketch a line, and I'm going to select kind of this front surface here to sketch on. Okay, and what we want to do is we're going to want to start from kind of the bottom here, and I'm going to just draw a line here to here. So, and then I can do a line from here to here. Okay, and then a line from here to here. So that should give me kind of something that is going to be representative. Now I'm going to come down, and let's make this one, I don't know, we'll make it 1.5 inches. Okay, and then I'm going to have a line come across here, and I'd really like that to be kind of perfectly down there. So let's try this one. There we go. Okay, so I can do that there, and I should be able to connect these lines. Okay, so now at this point I kind of have this kind of solid face coming in, and we're going to extrude this, and we're going to extrude it in, and so I'm going to hit E for extrude, okay, and this, and I'm going to come in this way, and again I'm going to come in negative 5 millimeters, okay, and you'll see that it's going to want to join because it wants to kind of make it a part of these other pieces, and we actually don't want that. We want it to be a new body because this is just going to be a separate piece for itself. Okay, so when we expand our bodies down, I should be able to kind of just see all these little individual pieces kind of coming together. Now what's good about this is that our back plate should pretty much look exactly like this one. And so we can, instead of having to go through that whole exercise again, we can just do a copy of it. To do that, we're going to go to Modify and go to Move Copy, or again, you can just use the M quick key. And for that, we're going to select on it, okay, and we're going to click Create Copy. So as we do that, if I move it at all, you can see how it's actually creating a whole separate copy. Now, we want to make sure that that gets kind of like perfectly aligned with that piece. And so what we can do is I'm going to kind of cancel that and show you an alternative way to do this. We do Move Copy, okay, and I'm going to select this body. We're going to create copy, but instead of just this free move, we're going to be using this point-to-point operation. And so if I click here, what I can do is I can select this point right here on the inside edge, and I can say, you know what, that should really be connected right there. And if I do that and click OK, you can see that it's now really perfectly lined up with that other edge. Okay. Now you'll notice that I positioned these pieces underneath it because when I'm looking at the top of the faceplate, I don't want to see kind of the seams of the other pieces. And that's why we're going to kind of try to limit all the geometry to the underside of this. Okay, next, let's go ahead and construct the sides. And so for this, again, for this, it's going to be a pretty simple rectangle. So I can click on my 2-point rectangle. I'm going to create that on this face. And I'm going to come from this edge right here down to this edge right here. Okay, pretty good. And that's pretty much as far as we need to go. So I'm going to hit extrude. So we're going to extrude this. And again, this time I'm going to come in -5 millimeters. I don't want to join. I want to create a new body and click OK. And again, I should now have a side. Now, with this particular case, we can't just duplicate it because this side is shorter than this side. And so they will be two different size pieces. So we can't just do that move copy trick. But it's not too hard to do another one of these. So we're going to click our 2-point rectangle. We're going to click on this side. And again, we're going to come from that point to that point. Okay. I'm going to extrude, again, in -5 millimeters. I want a new body. And click OK. Okay. Now at this point, you can see that I've got all these edges in here. And so all that's left is to do the bottom plate. Okay. Now for the bottom plate, I am going to not inset that, but rather make it kind of a cap piece. And so I'm going to kind of zoom out here. I'm going to do my rectangle again, 2-point rectangle. And I'm going to come from this point. Whoops. Stop sketch. Not sure what happened there. Okay, stop. Okay, we'll just try that again. I'm going to come up. I'm going to look at it from this angle maybe. And I'm going to say, okay, I want to sketch on this surface. That's better. And I'm going to come from this point all the way out to this point. And then again, extrude. And I'm going to extrude that down 5 millimeters. Okay, don't want to join. We want a new body. We click OK. Okay, and so at the end, we should have a completely concealed box. Ah, something interesting happened. So it looks like we had a little notch cut out here. Well, that's not good, but that's not a big problem to fix. So I can click on that, and it looks like we're probably going to have to drag that out 5 millimeters. And again, we don't want join. We want that as not necessarily a new body. So what I'm going to do is I'm going to turn off all these extra pieces, and I'm going to drag that out 5 millimeters. Okay, so now if I turn these all back on, I should have my completed box here. I'm going to turn off these sketches just for now. Okay, so I should have a completed box here. Okay, everything looks okay. It looks like it'll go together just fine. And now what we need to do is we need to get this all ready for laser cutting, because we're going to laser cut all these pieces out of wood. And so to do that, I'm going to come through and I'm just going to right click on each of the pieces that I'm going to want to laser cut. So that's going to be each of them. And what we're going to do is we're going to create a sketch out of them. So I'll click this Create Sketch. Okay, and you see that it adds a new sketch down here, and that's good. So what I'll do is once I've created that sketch piece, I'm going to hit right-click and save as DXF. Okay, I'm going to save it to my desktop, and I'm going to give it a name. So we'll call this MIDI, and I'm going to call this face left, because that's the faceplate and it's left. Okay, so I'll click Save. And then what I'm going to do is I'm actually going to kind of like hide that piece from view to kind of know that I've already kind of made a piece for it. And then I'm going to come over here and I'm going to click on this guy. Again, I'm going to turn off my sketches. I'm going to right click on this piece and create a sketch. Okay, so maybe take a quick second. Okay, well, looks like it's kind of freezing on me for a second, but we'll just let it sit for a minute and let it think about its life choices. Okay, looks like it didn't create a sketch, so I'm going to hit Stop Sketch. Make sure, try that again. So right click, right click, well, let's try and undo. Maybe I did something wonky. Okay. Oh, stop sketch. Okay. So again, I'm going to turn off my sketches, make sure I'm on bodies, right click, and there we go. It just wasn't selected. Okay. And so we're going to go through and we're going to create a sketch for each one of these pieces. And that should allow us to create these DXF plans that are going to kind of build up on here. And these are what we're going to go through and cut. Okay, so go through and just do that for each of your pieces. And that's going to be what we laser cut. The first time that we laser cut this, we're going to do this in foam core. Because again, if we need to make any micro adjustments, we want to do that with foam core before we spend all our time doing wood. And so as you kind of build out each of these pieces, cut it out in foam core, glue it all together, make sure it fits, put in your PCB, and if everything fits good, then you can go ahead and cut that out on wood. But you'll want to iterate on this until you get all those pieces together. Okay, one thing important to remember is each time you do this, you need to hit stop sketch before you move on to your next one. Okay, so I'm going to come back over here, and I'm going to right click and say create sketch. Okay, I'm going to save this as a DXF, and so this is the MIDI right. I can click save, and then stop sketch, turn it off, and then move on to your next piece. So go here, create sketch. Okay, right click, save as DXF, MIDI left, click save, stop sketch, turn it off, move on to the next piece. Okay, so almost done. Right click, save as DXF, MIDI bottom, save, stop sketch. Okay, and now that we're done with all those, okay, we're going to kind of come back here. We're going to turn all our bodies back on. Okay, and we're going to do a little bit of rendering work. So this looks okay, but we'd really like to make it look really nice. So at this point, I'm going to go ahead and save it. And call this, you know, whatever you want. Mine's going to be called MIDI sample. And we're going to move over to our render. Now at this point, it's kind of just rendering it in just regular neutral materials. So we're going to click on the Appearance tab here, and we're going to look through some options. We're going to be making ours out of some wood. So let's see, I've got bamboo light, ooh, oak semi-gloss, cool. So what I'm going to do is I'm going to just turn each of these pieces into oak. In fact, I wonder if I select everything, if I can just make it oak. Oh, fantastic. Okay, so there's my nice oak MIDI mixer. Okay, and at this point we're going to do a render, and so if we click on this tab, we've got some settings. So for me, I'm going to do a print. We'll do, let's do a 4x6. I do want to do a local render, and I'm going to go for just a standard quality. And I'm going to click render, and I'm going to do this from the isometric view, which is good. I'm also going to want to do this from a orthographic view, so we're going to do a front, a top, and a side render, preferably from the side where you can actually see that riser. So you can see down here that isometric view is rendering now. If we go over to top and again click render, you can load those settings again. Okay, and click render, and that's going to put those in the queue. So those will take a little bit of time to do. Okay, render that. And render that. And you'll want to include these on your documentation as well. Okay, so you can see these are kind of building up this queue. Once these are rendered, you can go ahead and export and save these and include them in your final documentation. Maybe while those are rendering, because those will take several minutes, you can go on over to the laser cutter and start cutting your foam core model. And once you have that all in good shape, then you should be ready to cut on the wood. And you'll want to glue up your enclosure. You'll use screws to mount your board inside the MIDI mixer and test everything out and make sure it's all working. And then you can glue the bottom on, and that should be good. One final thing that I neglected to include here is we need to cut an opening for the USB port. Okay, now depending on where your USB port is, you'll need to make accommodations for that. And so that is probably going to include extruding out a piece of this. So we're going to look at that real quickly. So we're going to come on over here. With mine, I measured it out a little bit, and we're going to come in here, and we're going to make a rectangle here. I'm going to do a construction line here, and I know that with mine, it is 15 millimeters by 12 millimeters here. Okay, so I'm going to do a construction line there. I'm going to draw a regular rectangle here. Okay, and that's going to be 10, easy there. 10 millimeters by 10 millimeters here. Okay, and once I have that done, then what I can do is I can go ahead and extrude this. Oh, nope, I want that one. Oh, come here. There we go. I'm going to extrude that -5 millimeters. And you can see with this operation it's set to cut, and that's okay, because I do want to cut it through. You'll want to make sure that you do that before you export all of your things, because you're definitely going to want the laser cutter to cut that out. And you'll just want to make sure that that's in line with where your USB is mounted from your Arduino. And so since I redid that one, I'm going to go ahead and right-click that and say, oh, I'm going to create a new sketch for that. So, okay, and we'll re-export that, and we should be in good shape. Okay, so if we go back over to our renders, okay, let's see how it's doing. Oh, looks like the first one is done. Okay, so that's going to pull that up. Looks really nice. And so I can download that, and I can save that to my desktop and include that in my documentation. And you'll want to do that for each of your renders. And that's it.